Hi, welcome to Math 1300, Nunez Community College. This section is section 4.3, and this section is going to be dealing with the remainder theorem, the factor theorem, and synthetic division. Synthetic division is an easier way to do division rather than doing it the long way like we learned when we were in grade school. Synthetic division only uses the coefficients in order to divide. So the first example says use synthetic division to divide, and we have a polynomial, 3x to the fourth minus 8x to the third plus 10x plus 3. And we want to divide by x minus 2. Now, in order to do that, we're going to use the coefficients. We're going to literally take the x's out, use the coefficients, and we're going to divide. The first thing is we're going to divide by what makes this a 0. So what makes this a 0 is if I write x minus 2 equals 0, bring the 2 to the other side, x equals 2. 2 in this spot would make this a 0. So when we divide, we're going to divide by the opposite of what we see if it's a binomial. So in order to divide, it's going to be a backwards L. I'll put in a 2. That's what we're dividing by. And now I'm bringing down coefficients. I have a 3, I have an 8, I have a 10, and I have a 3. However, when bringing down the coefficients, we have to look at the exponents for the variable. The exponent says to the fourth, so we have to have 1 to the third, we have to have 1 to the second. There is nothing to the second power. Well, that's a placeholder. So what we have to do is we have to add a 0x squared so that we have an x squared. So therefore there's a 0 in front of that, we put a 0 in. That's why I left a little room. So we have 0 for the x squared, we have a 10 for the x, and a 3 for the x to the 0 power. From here, we're going to draw a line, leaving a space, and we're going to drop down the coefficients and do the synthetic division. So the first term comes straight down, giving us a 3. And then using the synthetic division, we multiply what we have here in this box times each one of the coefficients to go into the next slot or the next column. 2 times 3 gives me 6, and then that's a negative 8, then we're going to combine them. So I have negative 8 and 6, which is negative 2. I then would multiply 2 times negative 2, giving me a negative 4. Combine 0 and negative 4, giving me a negative 4. Multiply 2 times negative 4, giving me negative 8. Combine 10 and negative 8, that gives me a positive 2. And then finally, 2 times 2, which gives me 4. The last thing that we have is an L, because this is our remainder. And we combine 3 and 4 to give me 7. So our remainder is 7. When trying to rewrite this in terms of the x's that we have, we would put this as, this would be x to the 0, just like that's x to the 0. This would be x to the first, because the second one is x to the first. This would be x squared, and this would be x to the third when putting our x's back in. So it's going to be written as 3x to the third minus 2x squared minus 4x plus 2. Then we're going to add our remainder. If this was a minus 7, it would be minus. Since it's a positive 7, we'll put plus 7 over what we're trying to divide by, which is x minus 2. This is synthetic division. And again, it allows us to divide a polynomial by a binomial that's given to us. All right, example number 2, we're talking about something called the remainder theorem. Now, the remainder theorem allows us to evaluate a function at a particular number. So we're going to evaluate the function the way that we're used to doing it first. Then I'm going to show you whether the remainder theorem would give us the same answer. So use the remainder theorem to evaluate p of x equals 2x to the fourth minus 5x to the third plus 6x squared minus 10x plus 6x squared minus 10x minus 3. And we're going to evaluate it at p of 2. P of 2. Which means if we're evaluating a function at a number, we plug in that number for the x's. So p of 2 is going to be 2 times 2 to the fourth minus 5 times 2 to the third plus 6 times 2 squared minus 10 times 2 minus 3. And therefore we would get 32 because 2 to the fourth would be 16 times 2 is 32 minus 40. 2 to the third is 8. 8 times 5, 40. And then plus what? 24 minus 20 minus 3. So therefore, P of 2, when we combine the numbers, is going to give us negative 7. So P of 2 would be negative 7. And this is literally evaluating that function at this number. Well, the remainder theorem is going to allow us to do the same thing using synthetic division. Okay? And the remainder theorem says we're looking at the remainder. So I'm going to draw a line. I'll bring these coefficients down like I'm doing synthetic division. So I'll have a 2, a negative 5, a 6, a negative 10, and a negative 3. And using synthetic division, I'm going to divide by the number 2. Now, notice it's the same number 2 because it says evaluate at 2. The last problem said divide by, and they gave us a binomial, x minus 2. Whenever it's in binomial form is when we divide by the opposite. All other times, we divide by the number that's given to us. So therefore, it says 2, we divide by 2. So now using synthetic division, bring down my 2, multiply, giving me 4, put it in the other column. I got a negative 5 and a 4, which is a negative 1. Multiply 2 by negative 1, giving me negative 2. I got a 6 and a negative 2, which is a 4. 2 times 4 gives me 8. Negative 10 and an 8 gives me negative 2. A negative 2 times negative, a 2 times negative 2 gives me negative 4 for a total remainder of negative 7. It's the same answer. So when we have a polynomial and they're asking us to evaluate at a certain number, we can do that. That would be fine to find the answer. Or we can use something called the remainder theorem. And the remainder theorem does the exact same thing using synthetic division, and the remainder is the answer. The remainder is the answer. All right, using the same techniques, the next thing we're going to have is going to be something called the factor theorem. The factor theorem. And the factor theorem is just like it sounds. It wants to show if a certain number is a factor. So it's the factor theorem. Okay? It shows if a number is a factor of a polynomial. So in the next one we have, we want to know, is x plus 2 a factor? Is x plus 2 a factor of f of x is equal to x to the fourth minus 7x squared minus 6. Minus 7x squared minus 6x, I think. Minus 6x, yes. And they want to know, is x plus 2 a factor? If x plus 2 is a factor, we should get no remainder because it should divide in evenly. So we're going to do synthetic division, And again, if we get no remainder, then it is in fact a factor. So we have what? The coefficient is 1, but I have no x to the thirds. So therefore, I must put in a 0. Then I have -7 for my x squared. I have -6 for my x, and I have no x to the 0 power, so we'll put that as a 0. Bring my line across. I'm going to divide by -2 because of the fact that it's in binomial form, and we're going to do the opposite. It's what makes this a 0. So now, when we do synthetic division, we bring down the first term, multiply, -2. When I combine, that gives me a -2. I'm now going to multiply -2 and -2 to get +4. And a -7 and a +4 gives me a -3. -2 times -3 gives me +6. When I combine, I get a 0. Multiply, giving me what? A 0. And therefore, when I combine, I get a 0. So in fact, there is no remainder. There is no remainder. So x plus 2 is a factor of this. So yes, it is a factor. And just kind of remembering what goes on, that means we divide it out in x plus 2. And what we have left is this, which is going to be x squared minus 2x minus, x to the third plus minus 2x squared minus 3x, because this is a 0, which would be plus 0. So this is what I would have left once I factor out in x plus 2. Okay, so the answer is yes, it is a factor. This is what we're going to do in order to solve an equation. And that's what's coming next. It says, if I have a polynomial, they want us to completely solve it if they give us a factor. So we're going to factor something out. We're going to be left with a smaller polynomial, because we started with x to the fourth, we would then end up with x to the third, and then from here, we would have to find a way, whether it's factoring it, whether it's doing the quadratic formula, in order to solve it from there. So let's look at the next example. The next example says f of x is equal to 3x to the third. F of x is equal to 3x to the third. Minus 5x squared plus 3x minus 10. Plus 3x minus 10. And they want us to solve the function. They want us to solve it given that 2 is a solution. Given that 2 is a solution. Which means we can factor out a 2. The first thing we do must be to prove that we can factor out a 2 to see what we have left. So they're telling us that 2 is a solution, factor that 2 out of this, and then see where we stand from there, okay? It's not in binomial form. It says just the number 2, so we're factoring out the 2. Synthetic division says bring everything down, 3, -5, 3, and -10. And we're going to factor out the 2. So I'm going to what? Bring my 3 down, multiply, giving me 6. Combine, which gives me a 1. Multiply, that gives me a 2. Combine, giving me a 5. Multiply, giving me a 10, and in fact, there is no remainder, so 2 was a factor. But they gave us that. They told us that. And they'll give you what one of the solutions is. So what I like to do at this time, though, is I want to put the x's back in, because just the numbers don't mean that much to me. But if I put the x's back in, I can see how to factor it. So this, represented with a number, would be x minus 2. because it's written as a binomial. Remember the opposite. And this would be 3x to the second plus x, and then what? Plus 5 equals 0. So this is what we factored out. This is what's left, and they're telling us to solve. Well, it would be nice if this would be a trinomial we can factor. You know, can we factor it saying, 3x and x and 5 and 1 and being able to do the outsides and the insides, but there is no way to factor it from there. I can't find a number that's going to multiply to give me 5 and 3 and add to give a 1. That's not going to happen. So we have to be more, we have to be creative. So I would say for this one, let's do the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All we have to know now is what is our a's, our b's, and our c's. So a would be, in this case, 3, b would be 1, c would be 5. And we're going to plug that in. So we have x equals negative 1 plus or minus the square root of 1 squared minus 4 times a, which is 3, times c, which is 5, all over 2 times a, which is 2 times 3, which is 6. And now when we start putting this together, I got x equals negative 1 plus or minus the square root of 1 minus, so I got what, 20 times 3 is 60, so that's negative 59 all over 6. And then to simplify from here, well, the only thing I can see that I can do is I can take a negative 1 out, and the square root of negative 1 is I, so that's going to be I square root of 59 over 6. And if I'm not mistaken, this is the answer, negative 1 plus or minus I square root of 59 over 6. But I think that when you're doing the Math Excel or the Cengage, you must split the denominator up. So it would be x equals negative 1/6 plus or minus I square root of 59 over 6. I think that's the way they have it. And of course the other answer is 2, which is what they gave to us. So if I wanted to write this in the form that they should want, it should be 2 as an answer, and then negative 1/6 plus or minus I square root of 59 over 6. That should be the form that they're asking for. Now, had this been a nice, easy number to factor, we would have factored it, and the 3 answers would have just been the 3 answers that would have been given to us. And finally, we now want to go backwards, and we want to write the polynomial function if they just give us the zeros. So they're going to give us zeros, and we have to write the polynomial function. So going backwards from divide would be multiply. Going backwards from divide would be multiply. It really is pretty super simple. We're just going to have to multiply multiple things. So it says, find the third degree polynomial, which tells me that x is going to be to the third power. Find a third degree polynomial, p of x, whose zeros is, so find p of x, whose zeros are 3, 3, and negative 5. So I got a 0 at 3, got a second 0 at 3, and I got a third 0 at negative 5. Remember, these are the zeros. They want the polynomial function, which means we need to put x's in here and we need to multiply them together. So if I write this using x's, it's going to be p of x is equal to the first one, which is x minus 3. And the second one, which is going to be x minus 3, because when we write it as a binomial, we have to do the opposite. And the third one, which is x plus 5. So if the 0 is 3, I got to write it as x minus 3. Same thing here. If the 0 is negative 5, I write it as x plus 5. Okay, because we're writing it in binomial form. So literally, we are now going to multiply the things together. But we can only multiply two things at a time. So the first thing I'm going to multiply are these two together. X minus 3 times x minus 3 would be foiling it together. So that would be what? X squared minus 6x plus 9. Because I'd have a minus 3x and a minus 3x to give me minus 6x. And that would be multiplied by x plus 5. And now I would say I have a binomial times a trinomial, so I'm going to distribute. So I got x times x squared minus 6x plus 9, which is that, times the whole thing. And then I got plus 5 times x squared minus 6x plus 9, which is the 5 times the whole thing. Distribute this, which would give me what? X to the third minus 6x squared plus 9x plus 5x squared minus 30x plus 45. And now it's just combining like terms, and that's going to be the polynomial we're looking for. I only have one x to the third. I have these two, so minus x squared. I have these two, so minus 21x, and then plus 45. So that's going to be combining, multiplying, given the zeros. That's going to be multiplying, given the zeros. And that concludes section 4.3. I will see you at the next one.